So everyone, today we're going to continue our presentations of data with box plots and cumulative frequency graphs. So let's get into it. All right, so first let's talk about how to draw a box plot, or otherwise known as a box and whiskers diagram. First, what you'll do is instead of scaling and labeling both your X and your Y axis, you only have to scale and label one axis. You'll plot the 5-number summary, or the big 5, above the axis. And what we mean by that is you'll find and plot your minimum value, your lower quartile, your median, your upper quartile, and your maximum value. From there, you'll box in your IQR. So from your lower quartile to your upper quartile, you'll box that in and then divide it at the median, wherever the median is inside that box. And then you'll stretch the whiskers, or you'll just draw straight lines out to your maximum value and to your minimum value. So let's do an example. So we have these heights in inches. And what we're first asked to do is just determine the 5-number summary. So we already know that we need that in order to graph it. So I'm going to use my calculator to figure out my 5-number summary. If you don't have a calculator, you can obviously just sort these from smallest to greatest and find those 5 numbers that way. Right, so I found my minimum to be 60, my lower quartile to be 64, my median was 64.5, so between 64 and 65. My upper quartile was 67, and my maximum was 74. So creating my box plot, again, we'll scale and label one axis. So this graph that you see here is a portion of what we call IB graph paper, where they always look the same, which is nice. That you'll see within this kind of bolded square, you'll have a 5x5 square of the smaller, fainter squares. So scaling it, just like with other graphs, it's kind of up to you to figure out how best to scale it. So I already kind of pasted out that if I start with this one, or even on the very left-hand side with 60 and count every 2, that I can fit them in. And labeling my one axis, these were heights, and we usually put how they are measured or what they're measured in, so in inches. Next, what I'll do is I'll plot those 5 numbers from my big number summary. When you plot these, it's really up to you how vertical you get or how high you go. I usually just try to pick one of the bolder lines and plot them on that. So I got my minimum value at 60, my lower quartile at 64, my upper quartile at 64.5. So if this is 65, because it's halfway between the two, I'm looking around here. My upper quartile is 67, and my maximum value is all the way over here at 74. Next, I'll box in my IQR, so from my lower quartile to my upper quartile. Again, depends on how tall or short you want to make this box. I'd say at least a couple of these smaller boxes. I'm going to go 3 up and 3 down, just because I'm a little particular when it comes to being even on both sides. But as long as it's deep enough or high enough that we can see where they are, where they're going, that's fine. And then I'm going to cut that at my median. So note that it's not always in the middle of your IQR. Finally, drawing my whiskers out to my minimum point, and you want these to be, same with the box, you want them to be as straight as possible. Obviously, in our virtual world, especially if you are like me and using a platform that doesn't have a straight line to use, it's a little bit harder, so we'll be a little lenient on that. But if you have a platform, if you're using a platform that has that straight line to use it so that it is a straight line. Or on paper and pencil, we would give you a ruler, ask that you use a ruler or a straight edge to make it as straight as possible. All right, part C, does the data contain any outliers? And if so, what are they? So we've talked about outliers before. So we'll go from, we're taking our IQR, remember, and expanding it to a wider range. And anything outside of that range is an outlier. So I'm going to go from my lower quartile and make it even smaller by subtracting 1.5 times the IQR through to my upper quartile plus 1.5 times that IQR. So that means my lower quartile, thinking back to my previous slide or looking back to the previous slide, my lower quartile was 64 minus 1.5 times my IQR. My upper quartile was 67 minus that 64 means my IQR is 3. Going up through my upper quartile, again, 67 plus 1.5 times that same 3. So that means I'm looking at this bigger range of 59.5 through to 71.5. Anything within that range is good to go. Anything outside of that range is considered an outlier. So all of my 60s are fine, but I have this 74 and I also have this 73, both of which are obviously higher than 71.5. So I'd have to say, yes, I do have outliers. And they also asked, what are they? So they're 73 and 74. Obviously, it doesn't matter what order they go in as long as you have both of them stated. So outliers in terms of our box plot brings up what's called a modified box plot. It's the exact same as our standard box plot, except that those outliers that we have are going to be plotted as separate points. And we usually represent them as X's so that it's a little bit more clear to see them. And that means instead of our whiskers being drawn all the way to those outliers, is that they're only going to be drawn to the last data point that's not an outlier. So let's use one or draw one for our heights. All right, so I've scaled and labeled my x-axis the same way that I did before. I also went ahead and transferred over my minimum, my lower quartile, my median, and my upper quartile. I'll fill in my maximum in a second because remember we have two outliers now. So my 74, which was my maximum, is no longer my maximum. Instead, my maximum is going to be the next highest after my 73 and my 74. So it's looking like it's going to be 69 is my next highest value. So when I go to actually create my box plot, my 73 and my 74 outliers will be marked as X's. My new maximum is 69. And then my other four values are the same. So just plotting them in the same points they were, or roughly in the same area that they were. And minimum of 60. And then this rest of it is the same kind of deal, boxing in our IQR, cutting it at the median, drawing whiskers out to my minimum and my new maximum, and then those outliers just stay there as X's. So what this does is it kind of creates not a better visual, but it really represents or really shows, hey, that whisker that went all the way out before, it's because we had a couple outliers there. A perfect box plot will have whiskers that are equal length on both sides and a median that's right in the middle of your IQR box. So this kind of evens it out a little bit, but it just gives you a visual representation of those 5 big number summaries. All right, and the last thing we'll talk about with box plots are side-by-side or parallel box plots like we see here. And what they do, or their purpose, is they'll compare 2 or more sets of data. So like, for example, in this distribution of gas mileage, we have 3 different box plots all together. So instead of looking at 3 separate box plots in 3 separate diagrams, they're all in one. In order to create this, what we usually do is we'll still scale and label one axis. So our miles per gallon was what they were looking at. They would have plotted this first box plot on the bottom and labeled it. They chose to label it by also kind of scaling and labeling the y-axis. So this one on the very bottom represents vehicles that have 3 gears. And then you would plot the other box plots above it and label them. So this one in the middle had 4 gears, and obviously the one on the top had 5 gears. One final thing to point out with box plots is just to remind you, or kind of connect the pieces, that with this big 5 summary, I'm going to use this box plot on the bottom, we had those 5 numbers that we would have plotted, and remembering that those 5 values cut that 100% of your data into 4 separate sections that each represent, even though they might not look it, each represent 25% of your data. So between your minimum and your lower quartile, that's 25% of your data. Between your lower quartile and your median, that's another 25%. Your median to your upper quartile is 25, and then your upper quartile to that maximum value is another 25. So just remembering that even though it might not look it, that's the point of your lower quartile, your median, and your upper quartile, that it cuts the data in half for you and then in half again for your quartiles. So just remembering that can help you with some IB problems.